Hi everyone. Today our team from UTT pleasure to introduce our research development of deep learning neural network for estimating pi-bearing capacity. Our presentation divided into 5 parts. Part 1, introduction. Part 2, materials and methods. Part 3, data use. Part 4, result and discussion. And final conclusion. Part 1, introduction. As you know, the Asian bearing capacity of pi have to be determined when designing pi foundation. Throughout years of research, there are many different methods used to calculate the bearing capacity of the pies. For example, static pi load test, dynamic load testing at fields, or empirical equation used in situ test results, and finite element method. It having to say that each method has its advantage and disadvantage. For example, field testing methods are time-consuming and costly, while empirical formulas have make it difficult to choose the right coefficient for the parameters. And finite element models are too sensitive to input parameters. In recent years, machine learning methods have proven to be dominant in many fields, including construction. Many machine learning models, such as ANN, SVM, and FISH, have been developed to use to predict the Asian load capacity of pies. With recent development of deep neural network, it has brought great success in many subjects compared to its predecessor ANN. However, it is difficult to find an optimal deep neural network architecture because the model contains a huge number of hyperparameters. The main purpose of this study is to develop the most suitable architecture model ANN to predict the pi-bearing capacity. Part 2, materials and methods. 2.1, deep learning neural network. DNN is a type of ANN consisting of multi-hidden layers to connect the input to the output layer. Since it contains more hidden layers, it allows a better prediction of relationship between input and output, especially the large amount of data containing many input dimensions. The DNN model used in this study is developed from the general multi-layer perception model. 2.2, performance evaluation. In this study, we use two performance indicators to confirm the performance of machine learning model. First, square correlation coefficient is closer to 1, the higher model performance. In the other side, root mean square error value is smaller for better model. Part 3, mod data use. Data is important to the machine learning model. And in this study, we use a total data of 472 static pi load test reports from construction site in Hà Nam, Vietnam, and includes all the pi and soil parameters that may affect the pi-bearing capacity determination. And all the summarized statistics of the data were shown in table 1. It includes mean value, average value, mass value, and standard deviation. Part 4, results and discussion. First, the effect of training data set. In this study, the original data set is randomly divided into 3 parts: training set, validation set, and testing set. The testing part takes 20% of all data set, was hidden through the training and modifying model process, and only used to confirm the performance of the last models. And the training set size was chosen from 60 to 20% of the rest of the data. For more objective results, 300 random sampling of the training and validation set were performed to each value of the training set size. The performance of the DNA model using different training set size was shown in figure 1. You can see that with 60% of the training set size, the model accuracy reached the highest and most stable on both training and validation set. More specifically, the average performance is I-squared by 0.909 and 0.891 on the training and validation set, respectively. But for point 2, development of DNN model architecture. In this study, we use a research technique to find the best DNN model. In this technique, two-dimensional array containing the number of hidden layers and the number of neurons in each hidden layer were used to detect the most optimal architecture of DNN model. As the hyperparameter space can be shown in table 2, it can be seen that the number of hidden layers range from 1 to 10, while the number of neurons in each hidden layer range from 50 to 100. In this test, we use training and validation data set and two cost function, root mean square error and I-square. The result of research technique was shown in figure 2. And it can be seen that the result shown in table 3 shows that there are 4 top performing DNN models with the number of hidden layers range from 1 to 4. And to select the best model among 4 good models, a Monte Carlo simulation based on 300 random sampling of the data set were performed. And the result of Monte Carlo shown in figure 3. It can see that among the 4 good models, the model with 2 hidden layers shows the good performance and give the best prediction, which yield average correlation of I-square by 0.903 and root mean square by 105 of the testing set.
Sorry, you
3,
have 2 minutes.
2 minutes. Thank you, Mr. Khương. And the regression graph of high bearing capacity using the final DNN model was shown in figure 4 with A, training set, B, validation set, and C, testing set. You can see that the model with 2 hidden layers and 70 neurons in each hidden layer gave a good, stable performance and does not face to overfitting problem by showing excellent performance on all data set, especially the testing set. And part 5, conclusion. The results show that among the DNN architect survey, the model with number of hidden layers less than 5 had a better performance than the other. The DNN model with 2, 3, and 4 hidden layers show outstanding performance compared to shallow neural network. And the sui-able neuron in each hidden layer range from 20 to 70. The model with 2 hidden layers and 70 neurons in each hidden layer performs the best accuracy, stability than the other model. And this study shows the potential of the DNN model in estimating the bearing capacity of the pi while reducing the cost and time of testing the pi in the field. Our presentation is end now, and thank you, John, for your kind attention.
Thank you, Dr. Phạm Tuấn Anh. It's an interesting presentation too. And you focus on the prediction of the bearing capacity of the pi foundation. And you collect the more than 470 static pi. Very well. Very well. Yeah. And you propose a structure. It's short time. Okay. You propose a structure for deep learning model. Interesting. Do you have any question for Dr. Phạm Tuấn Anh, please? Okay. Okay. Please invite Dr. Bang for the question.
Yes. Thank you, Mr. Tuấn Anh, for your contribution. I have just one question. what is your criteria for the selection of the number of hidden layers? Because it is varying from 1 to 10, and also the number of neurons in each hidden layer, which is up to 100 neurons in each hidden layer, I think. So what is the choice of these range for your problem? Thank you.
What is the choice?
So, I mean, what is the criteria? The criteria for the selection of these values.
Criteria in this survey, I use root mean square error and I-square, and you can see here some model have a good I-square, but some good in root mean square error. So I choose all the similar model here to survey in next Monte Carlo simulation based on 300 sampling with both with all 4 root model. Some model have good performance in I-square, but some have good in root mean square error. I don't know how what model is better, so I use all 4 model to run in a simulation, and
choose the best one.
Choose the best one among 4 root model, and you can see in figure 3. Use two criteria.
So I think that model have higher R-square and lower RMSE, right?
The average and the standard deviation is better. Is the best among 4 models.
Okay, just one little question. Have you ever tried more criteria such as MAE or MAPE and test how these criteria are different or not?
Yeah. In the first study, we use quite a lot of criteria, but because of the limit of the paper by Sigurd, so I remove them and only use 2 criteria.
Yeah, thank you.
Thank you.
Okay, thank you.